Task 1. Configure BGP between the backbone and enterprise networks. This is Lab 2. We have HQ, Branch 1 and Branch 2. These are the enterprise networks, and these enterprise networks are going to connect to the backbone network through BGP. So each enterprise network has its own autonomous system. HQ has autonomous system 65103. Branch 1 has AS number 65001. Branch 2 has AS number 65002. And they are going to connect to the backbone routers through BGP. And the backbone has autonomous system 65100. So different autonomous systems connect through eBGP or external BGP. This is task number 1, is to configure eBGP between each enterprise branch and the backbone router. So HQ P1 is going to connect through eBGP with P2. PE1 is going to connect through eBGP with PE2, and PE3 is going to connect to PE4 through eBGP. I have prepared the script for this task to establish eBGP peering through loopback 0 address. So each router is going to connect through loopback 0, and we will use loopback 0 on each router as the BGP router ID. So P1 loopback 0 is going to connect with eBGP to loopback 0 on P2, and same for the other two eBGP peering. There is no routing for the loopback, so we will configure static routing. On P1 we need to get the loopback address of P2. The loopback address of P2 is 10.0.6.6. This is why I have to configure IP route static route on P1 for the destination network, which is the loopback address of P2 10.0.6.6 and its submask /32 and the next hop address. The next hop address is 10.0.0.14. On P1 the next hop address is the IP address on interface Ethernet 100 on P2. Let's check that. On P2, display IP interface brief, and we can see that Ethernet 100 on P2 has IP address 10.0.0.14. This is the next hop address for P1 to get the loopback address of P2, which is 10.0.6.6. And on P2 we have to configure a static route to the loopback address of P1. On P1, display IP interface brief, and the loopback address of P1 is 10.0.5.5. And the next hop address for P2 to get the loopback address of P1 is the interface Ethernet 100, which is 10.0.0.13. Back to the topology, and this is the interface that we stated. It's Ethernet 100, and this is the static route that will be configured on P2. So let's copy the first static route on P1 and paste it into the system view of P1. And I'll copy the static route that should be configured on P2. This is the loopback address of P1, 10.0.5.5. So on P2, we will go to the system view using system view immediately, and I'll paste the static route. Now P2 can get the loopback address of P1, and same for P1 can get the loopback address of P2. We can test that using ping and -a and the source IP address. I will initiate a ping request on P2 with a source address of loopback 0, which is 10.0.6.6. And the target IP address or the destination IP address will be the loopback address on P1, which is 10.0.5.5. And now I can get reply, so it means that the routing over the loopback addresses between P1 and P2 are working properly. I will do the same for the other routers. On PE1, I'll configure a static route to point to PE2 loopback address. Right click on it, copy and paste into PE1. We have to go to the system view and I'll paste the static route. This is the static route for loopback 0 on PE2. And on PE2, I'll copy this static route for the loopback address of PE1. System view immediately, and I'll paste the static route. And now I can ping -a 10.0.2.2, and the target IP address is 10.0.1.1. And I can ping last two routers, PE3 and PE4. I'll copy the static route for PE3. System view immediately, and I'll paste the static route for the loopback 0 interface of PE4. And I'll do the same for PE4, copy and paste inside system view of PE4. Paste, and we can test the connectivity using ping -a 10.0.4.4. This is the loopback 0 interface of PE4, and the target is the loopback 0 of PE3, 10.0.3.3. And now I can ping. Next is to configure the eBGP peering between each two routers, P1 and P2, PE1 and PE2, PE3 and PE4. On P1, I will configure the BGP with its autonomous system number, or the AS number is 65103. This is for P1. And the router ID is the loopback 0 address of P1, which is 10.0.5.5. I'll configure the BGP router ID using command router ID under the BGP view. Router ID and the IP address is 10.0.5.5. After that, I'll configure the peer. Here, the peer will be the loopback address of P2, which is 10.0.6.6, and its AS number is 65100. After that, I'll press enter and I will configure the peer with command connect interface loopback 0. Peer and the peer address and connect interface loopback 0. This is to guarantee that the source of the BGP packets that will be sent from P1 will be with the IP address of loopback 0 of P1, because the loopback 0 of P1 will be configured on P2 as the target IP address for the eBGP peering. So I must guarantee that the source is loopback 0 on P1 and same on P2. Here I must guarantee that the source of the BGP packets is loopback 0 of P2. Otherwise, the eBGP peering will not be established. On P2, we will configure the BGP peering, the BGP AS number 65100, the router ID is loopback 0 of P2, and here the peer 10.0.5.5 with its AS number, and the peer with connect interface loopback. I'll copy the prepared script for P1, right click on it, copy and paste inside the system view of P1. Here I have got an error that BGP is already running and its AS number is 65001. AS number must be 65103. I'll double check the configured BGP, display current configuration, configuration BGP, and here I can see just BGP 65001. I cannot configure two different AS number on the same router. So I will remove this AS number, undo BGP, and the AS number 65001. It's warning me that BGP process will be deleted, and it asks me to continue I will press yes. I'll copy again the configured BGP script for P1 and paste. Now I have configured the prepared script for BGP on P1. I'll do the same for P2. I'll copy this configuration script for BGP to be configured on P2. I'll copy and go to P2 and paste here. And I will do the same on PE1 and PE2. BGP 65001, this is for PE1, and the router ID 10.0.1.1, and the peer address is 10.0.2.2, which is the loopback 0 interface of PE2, and its AS number 65100, and last command is the peer address and connect the interface loopback 0. I'll copy this prepared script, go to PE1 and paste. And I will do the same on PE2. Router ID is loopback 0 of PE2 and the peer address is PE1. And I will do the same on PE3. I'll copy the configuration for PE3 to pair with PE4. And last router is PE4. I'll copy the prepared script for PE4 and paste it into PE4. Now I have finished adding the required eBGP configuration to establish eBGP peering between the enterprise networks and the backbone network. Back to the topology. On PE2, I will check that BGP peering is established with PE1, and I will do the same on P2 to check that the eBGP peering with PE1 is established, and I will do the same on PE4 to check that eBGP peering is established with PE4. The command that is used to check eBGP peer relationship is display BGP peer. I'll copy this command and paste it into the three routers of the backbone network: PE2, P2, and PE4. Here I can see that the peer is added, but with state idle. On P2, display BGP peer, and I can see that the peer is still idle as well with P1. And same for PE4, display BGP peer, and I can see the peer but with idle state, not established. The eBGP peering between the routers didn't come up. We have to troubleshoot and check the configuration. We have to make sure that on P1 we configured the loopback address of the target router P2 correctly with its correct AS number 65100. Let's check that on P1. I can see that the BGP AS number is 65103 on P1, and the local loopback address of P1 is configured correctly, and we configured the target loopback address of P2 correctly, 10.0.6.6, and its AS number is 65100. But display BGP peer, I cannot see the BGP peering in established state. I can see it's in idle, which means that it's not working. We have to know that eBGP peering working only on the direct physical interfaces. This is by default. eBGP peering can be established just on the physical direct interfaces. But in our example, we configured the loopback address of P1 as the source from P1, and the destination is the loopback address of P2. And we did same on P2. We configured the local loopback address of P2 as the source of the BGP, and the target or the destination of the BGP is the loopback address of P1, which makes that P1 and P2 trying to establish a BGP peering on non-direct interfaces. In this case, a BGP peering will not be established by default, and we will face the same issue between PE2 and PE1 and between PE4 and PE3. To recover this issue, we have to configure eBGP maximum hops to configure the hops allowed for the eBGP to establish between non-direct interfaces. So if we configured the maximum hops as 2, the eBGP peering should be working. Because for loopback interfaces, if loopback interfaces are used to establish eBGP peer relationship, the peer eBGP maximum hop command must be configured with more or equal to hops so that the peer relationship can be established. Because if one hop, it means that it's a direct connected interface. So we will configure the maximum hops as 2 hops. Let's try that on P1 and P2. On P1, display current configuration BGP. I will add here another command, the peer and the peer address and maximum hops as 2. But before I add this, I will check the BGP peer relationship status. The peer 10.0.6.6 is in idle state. System view immediately on P1 and right click the BGP AS number and copy the peer and the peer address and add the keyword eBGP maximum hop and 2. 2 or more is accepted for the eBGP peering that is based on the loopback address. Enter to apply this command, and I will do the same on P2. System view immediately, display current configuration BGP and BGP 65,100, and I'll copy the peer and paste it here and add eBGP maximum hop 2. Display BGP peer again on P1. I'll exit and display BGP peer again, and I can see that the BGP peer status is in the established state. Before applying the command eBGP maximum hop 2, it was in idle state. So it must be configured with hops more than or equal to. If is not configured, the eBGP peering must be established on the physical interface.